All right, you ready? Growth or decay? Growth or decay. Today you're going to decide whether functions are growth or decay. Okay? Let's remember y equals b to the x. What is true about growth? B has to be greater than 1. Good. And then decay. What has to be true about decay? Enough. Does that make sense? But we need to talk about another way to look at this. Okay? Because there's another formula type thing that I want you to be aware of that you'll be using today. Okay? What about this? What if it said this? Oops, that's supposed to be an R. Pretend that's an R. It's just a lowercase r. I know it's giant. I'm sorry. Between these two formulas right here, which one is growth and which one is decay? The one with the plus is growth, right? Because wouldn't that be greater than 1? And the one with the minus? That's decay. Does that make sense? Okay. What do you think R stands for? Kind of, but I want to know like what actual word does it stand for? Rate, right? And how is a rate usually presented to us? A percent, right? A rate is a percent, okay? So we're either going to have to like put it in to decimal form, or I might even ask you to take it out into a percent form. Does that make sense? Okay. So these are the two ways that we're going to look at this today. But let's go ahead and start off with the easy ones. Are you okay with that? Because like I said, I'm going to ask you to identify whether equations are growth or decay. Okay? So we'll start off with these three. Y equals 5 to the x, y equals 1/4 to the x, and y equals 5/4 to the x. Those are the three we're going to start with. This first one, is this growth or decay? How do you know that it's growth? The base, that 5 is greater than 1. Could you write it in this form for me? Y equals a, because I don't know what it is. It's probably 1. In fact, it is 1, but we're just going to have the a there for a minute. Okay. 1 plus what equals 5? 1 plus 4 to the t power? Aren't those two basically the same? Except for the a part. I'll explain the a part in a minute. You okay with that? So what's the rate at which this is growing? Remember how I told you that this was a... But it's not a percent. I have to put it into a percent. If it starts at 4, where does it go? 400%, right? It's growing. It's going to be, yeah. Okay. All right, what about here? Is this growth or decay? Decay. Can you rewrite it into this form right here? Y equals a times 1. 1 minus what is going to equal 1/4? Oh, 3/4 to the t power. Well, 3/4 is what decimal? 0.75, right? And so what rate is it decaying at? 75%. Does everybody understand that? Okay. What about the last one? Is it growth or decay? Oh, see, I tried to trick you. Did you notice that? Why? How did I try to trick you? By a fraction, right? Because some people think if it's a fraction, it's decay. I mean, kind of. Because isn't a fraction usually between 0 and 1? Yes, but are all fractions between 0 and 1? No, so please don't be tricked. This is growth. So can we write it in this form right here? Y equals A times 1 plus 1/4 to the t power. Yeah. Okay. Any questions about this? All right, so those were the easy ones, because first of all, in your homework, it's going to give you this and ask for growth or decay, right? That's all it's going to do, and then it's going to ask you to graph it. Well, it's on big ideas, right? So are you physically having to graph it yourself? No, you're choosing one of the graphs that's there, right? Now, what are you doing for your homework? Are you doing an exact sketch of that, or are you doing a quick sketch? Quick sketch, okay? We talked about graphing specifically yesterday, so today we're worried about quick sketches, okay? So here are the problems that become problems, basically, okay? Y equals A times 0.5 to the t over 28 power. Do you see why I said it becomes a problem? Why is this a problem? Why is this an issue? Yeah, we can't have anything in our exponent except for t or x or something like that, but this 28 is here, okay? So can I show you what to do with this? Yes? Okay. Here's what we do with it. We have our a, we have our 0.5. We know exponent rules. And exponent rules say that I can take this fraction right here and change it to be that, right? I also know exponent rules, and so I know that I can take this and change it to be that. Because if a power means I multiply. Well, if power of a power means I multiply, doesn't multiply mean I can do power of power? Well, isn't 0.5 raised to the 1 over 28th power something I can just put in my calculator? You all have your calculators out, right? Oh, good idea. What is 0.5 raised to the 1 over 28th power? .976? Yes? To the t power. 0.976 to the t power. Is it at a point now that I can determine growth or decay? How do you know you can determine it now? The t is by itself. Okay, you have to isolate the t, and then you can decide if it's growth or decay. Okay? Now, because of what's coming next, I'm going to do one more step before I write whether it's growth or decay, but can you tell me whether you think it's growth or decay? Decay, right? But I'm going to go ahead and write it in this form, like I did earlier. So in this case, it's 1 minus something. 1 minus what gives me 0.976? How am I going to figure that out? What are you putting in your calculator, though? Yeah, you're literally doing 1 minus this to figure out what it is that you have to subtract from 1 to get to here, right? So what is 1 minus what equals 0.976? 0.024. Now tell me officially if it's growth or decay. Decay. And now tell me by what rate is it decaying? 2.4%. Does that make sense? Yes? Should I do another one? Yes? Okay, I'd be happy to. Y equals A times 3 to the 1. Oops, sorry, this is a t over 4 power. Can we take a commercial break real quick? Look back at this problem we just did. why in the world am I dragging this A along the whole way? Could I have done the problem without the A? Does the A make any difference whether it's growth or decay? No, it does not, right? It's the B that determines growth or decay, right? So why did I have this A here? In some of your equations, will you have an A value here? Yes, you will. And so I wanted you to get used to having an A value there, whether it's an A or whether it's a 7 or whether it's a 1/2 or something. So I want us getting used to having a number there. So that's why we drag the A along. Plus, if it gives it to us in the beginning, we have to drag it along, don't we? Because it's part of the problem. Okay? So I have an A in this problem as well. You all right with that? All right, what should I do first? Get the T by itself. How are we going to do that? 3 raised to what power? 1/4 times T, right? Then what can I do with the 1/4? So 3 to the 1/4 to the T power. Well, what is 3 to the 1/4 power? Y equals A times 1.312. Is that what you said? So 1.316. Yeah, we're going to 3 decimal places. We're rounding to the thousandth. Okay. Sorry if I didn't make that clear. That's on me. 1.316. We good with that? Where do I have to go last? Is it 1 plus something or 1 minus something? It's 1 plus what? Now, does that seem like a really obvious question to you? Because if I say 1.316 is 1 plus what?